Right, folks. Today we'll discuss about analytics and how you can use it in a business, but not the scary, mathy jargon field kind. You want to know these things actually mean and what you're supposed to do with them on a Tuesday afternoon when you are just trying to make a decision. I get it. Everyone throws these terms around in meetings. Like, for example, we need to leverage predictive analytics to synergize our forward facing KPIs. And everyone nods, and you're thinking, you have no idea what that means, do you? So let's cut through that. Let's tell a story and imagine a company where we will call it, let's say, uh, been there, done that. It's a small chain of coffee shops. They're doing okay, but they're guessing. They're guessing what coffee to brew more, or for they guessing where to put a new store. They're guessing why customers stop coming. Meet, for example, Maria. She she's one person there who's tired of guessing. Her job is to turn guesses into decisions. And she uses analytics, but not all at once. She starts simple. First, she just wants to know what happened. This is the most basic form, descriptive analytics. It's just looking in the like a rear view. It's not telling you why. It's just telling you what's happened. The specific term you will hear here is KPIs or key performance indicators. These are just, vital signs for a coffee shop. That's stuff like daily sales or like customer count, average order value. Maria's practical usage could be like, for example, every Monday morning she doesn't just look at a spreadsheet. She makes a simple dashboard, a line chart showing sales by day of the week. She immediately sees this, massive repeating spike every Saturday. Okay, great. So you can ask, what's the practical takeaway? Do not schedule your new barista training on Saturday. Stuff up. Make sure you got extra beans roasted. This isn't rocket science. It's just using your eyes on organized data. But then she sees something else. Her average order value on a weekdays is higher than on weekends. Why? She doesn't know yet. She just describes it. That's step one. So in other words, it's about clarifying the problem itself, not like uh, immediately trying to figure out what's a solution. So now she needs to know why it happened. This is the next level. That's the diagnostic analytics. Sounds like we're visiting a doctor, isn't? This is where you go from being a porter to being a detective. You're digging for clues. The specific term here is a drill down and correlation. Um, Maria takes that uh, weekday versus weekend mystery. She drills down. She filters the data only for weekdays between 7 and 9 a.m. And she finds something. A huge number of people ordering a coffee and a breakfast sandwich. That's why the average ticket is high. Um, the morning rush is commuters grabbing food and coffee. Then she looks at weekends. It's mostly just, coffee orders. People are lingering. They're not in rush. They're not buying as much food. She also checks for correlation. This is a fancy word for, do these two things move together? She plots two lines on a chart, one for daily temperature, one for iced coffee sales. And no surprise, when the temperature line goes up, the iced coffee line goes up. They are correlated, they move together. So, practically speaking, now she knows why the weekday average is higher. So, in other words, before she knew the problem, now she gets to know what's causing this problem. Uh, Practical things to do. Maybe on weekdays you promote the combo deal. For example, I don't know, coffee and sandwich for $10. On weekends, you don't bother. And for the temperature correlation, she knows to check the weather forecast if it's going to be a hot week. She tells manager to order extra iced coffee ingredients. This is no longer a guess; it's a calculated move. You just have to, you know, uh, use logic in this scenario. You don't have to have PhD. Just look up the forecast, and if it's going to be very hot, just order some ice. All right, now Maria gets ambitious. She wants to see the future. Well, not see it, but make a really, really educated guess. And this is called predictive analytics. This is where it feels like magic, but it's really just patterns. Um, the specific term you hear here is forecasting. Maria has years of sales data. She knows that every December sales goes up by 20% because people are buying bags of beans as gifts. She uses a simple forecasting model in Excel. She feeds it all the past data, trends, the seasonal spikes, and it draws a line into the future. It predicts that next December she will need 20% more beans than usual. Practically speaking, here she doesn't wait until December 1st to panic order coffee. She places the order with the roaster in October, locking in the price and guaranteeing the supply. She hires temporary holiday staff in November. She's ready. She's not reacting, she's acting. In other words, she's being proactive rather than reactive. That's the power of prediction. But she wants to get even smarter. She has a list of 10,000 customers from their loyalty program. She can't talk to all of them, so she uses clustering. This is another predictive technique. Um, the software looks, at all the customers' data, how often, for example, they come with what they buy, how much they spend, and it automatically groups them into clusters. It like finds the patterns. It might speed out three, for example. Uh, it might speed out three clusters. Cluster A, the let's say the daily commuters, high frequency, always before 9 a.m. Before buy coffee and food. Cluster B could be, for example, the weekend regulars. Come every Saturday, just get coffee, hang out for an hour. And cluster C could be the occasional treat group. Come once a month, spend a lot of fancy lattes and pastries. And practical usage here that this is marketing goal. Maria doesn't send generic, like say 20% off your next coffee email to everyone. That's wasteful. To the daily commuter, she sends an email at 6:30 a.m. Running late, skip the line, pre-order your usual on our app to the weekend regulars. She sends one on Friday. Your quiet corner is waiting. Enjoy a free pastry with your coffee or this Saturday. To the occasional treat group, she says, "We miss you. Here's a treat on us for your next visit." And the response rates skyrocket because she's speaking directly to their behavior. And finally, we get to the whole grail. It's another term, an analytical term for business, which called uh, prescriptive analytics. Sounds like we gotta have prescription, but this is the what should I do? This is the uh, like a system, not just predicting the future, but like a telling how you get the best possible outcome. The specific term here is optimization. Maria is trying to figure out the perfect amount of um, baristas to schedule for each hour of the day. Too many, and she's wasting money on labor, too few, and the line gets long, customers gets mad, and she loses sales. She uses, an optimization model. She feeds it data, historical customer arrival times, how long it takes to make a drink, the cost of labor, the value of a lost customer. She sets a goal, maximize a profit. The model doesn't just, predict the busy times. It prescribes a solution. It says on a Tuesday, schedule 3 baristas from 7 to 9 a.m., two from 9 to 11 a.m., and one from 11 a.m. onward. This is the optimal setup to maximize profit on all the constraints. And practical example could be that Maria stopped spending 2 hours every week trying to uh, build a schedule based on a gut feeling. The model builds the first draft for her. She saves time, reduces labor costs, and keeps lines short. It tells her like the best possible action to take. So again, instead of um, relying to the gut feeling, you have to rely to the solid facts, data. So there, there you have it. It's a journey, and let's wrap it up. Too long didn't treat kind of style. What kind of terms we discussed, and like simply speaking, their meanings. So descriptive analytics, it's about what happened. Like in other words, describing the problem. Like look at your KPIs on a dashboard, for example. Then we discuss diagnostic analytics, which about why did it happen. In other words, what what exactly caused the problem. For example, drill down and find correlations. Then we discuss predictive, what will happen. In other words, based on that, we try to figure out what could happen next. Use forecasting and clustering to get ready. And finally, we discuss prescriptive, what should I do? That's about using optimization to make the best decision. In other words, simply speaking, we figure out problem, its root, and based on that, we uh, try to be proactive in order to prevent this kind of and another problems in the future by using different techniques, tools. And again, it's not about being a math genius. It's about being curious. It's about stopping yourself from guessing and asking what does the data want to tell me, and start with a rear view mirror, and understand what just happened, and slowly you can start to navigate the road ahead. And thanks for listening. If you like it, you know what you have to do. See you next